First of all, I will say a few words about Saab Aeronautics, just to set the stage, and then we will talk about software quality from two different perspectives. First, Niklas will give us the process owner's perspective, and then Claes will give us the system architect's perspective. So, of course, I mean, these are two sworn enemies, as you can see. Now, all jokes aside, of course, we will try to, provoke a bit two different viewpoints, just for fun, okay? But also to give everyone here a view of that. Well, quality is not set in stone exactly what that is, right? And then we will have pizza and enjoy each other's company. Right. So Saab Aeronautics, like I said, that's where I work with software strategy, and it's basically the business area for big flying things at Saab, because we are 4 business areas. Apart from us, there's Dynamics, and they make small flying things and smaller things in general. And then we have Surveillance, and I think their name suggests what they do. They make sensors and radars and things like that, right? And then we have Kockums, and that's the water business area. So they make surface vessels and underwater ships and things like that. Saab was founded in 1937, and aeronautics was, airplanes was what we started out with back then. Now we are well over 6,000 employees at aeronautics, probably more than 7,000 by now, because we're growing rapidly. And at Saab, more than 26,000. Aeronautics has 4 business units. Gripen, I think you've all seen this. Bird flying over Linköping, that's what we do at it. Develop at the Gripen business unit. Not only the airplane, of course, but support and training systems and things like that. And then we have aerospace systems, and they basically make things for airplanes for other companies like Boeing and Airbus, and things like that. For example, they make a large part of the T-7 trainer that will be used by the US Air Force. And then we have aviation services, and they do maintenance and things like that, service for aircraft. Not only Gripen obviously, but also other aircraft. For example, the Swedish firefighting aircrafts are maintained by aviation services. And then we have advanced programs, and their task is to look ahead beyond the Gripen. What will we do then? What is needed in the future of air defense? And our operating countries where we have production is obviously Sweden, but also in Brazil and the United States. Okay, so that's aeronautics. Enough about that. Any questions? No, because you're not here to hear me talk about aeronautics. You're here to talk about software quality. So, what is software quality? Let's see what ChatGPT says, because that's the answer to everything these days, right? I asked ChatGPT to summarize software quality in 3 words, and it came up with reliable, maintainable, and usable. Does that make sense? Not bad, right? Yeah, could be right. Let's see if you agree with, if you are as smart as ChatGPT. That will be interesting, I think. Right, so let's keep this in mind. Reliable, maintainable, usable. Well, maintainable seem to agree on that at least. Secure, yeah. We have usability over here, so at least it's on the page. Right. It is? Yeah. That's just... What right? This right? Oh yeah, that's right. Yeah. Good. Yeah. Okay, someone here has been using lousy software, I can tell that. Well, that's good. Well, obviously, what we can see is that it's not so easy. It's not just one thing, right?
It's all that. You do all that and you're fine.
Yeah, you do all that and you have quality. Well, like I said, we will give you at least two different perspectives now on what software quality can be. So, and please, I encourage you to ask questions throughout the presentations and get the dialogue going. Okay? And if you don't dare ask any questions, like I said, we will be here afterwards as well. So, but let's start with, oh, sorry. Okay, just going to take a short technical break, and now it's over. So I'll leave the word to you, Niklas. Welcome.
Just clicking.
Yes.
So, hello. What is software quality from my perspective, the process owner's perspective? So first of all, I need to present myself, I suppose. My name is Niklas Pettersson. I am 32 years old. I studied here in Linköping, computer science and civil engineering. And I have been working at Saab Aeronautics for about 7 years. I have different roles or, well, responsibilities, both formal and non-formal. The more advanced one, or the one higher one, being the process owner for developing software for aeronautics. So what aeronautics is supposed to follow and do. But I'm also the software architect for the flight critical domain in the Gripen E system, and the something called applications manager for the mission critical domain. So it's both the cool parts with the radar and the screens, and the parts that makes the aircraft really fly, the flight critical domain. So that's what I do at work, and at my very limited free time, I used to spend the time standing in Saab Arena screaming at ice hockey teams, and I cook some food. That's basically what I do at my free time. So, again, what is software quality? You had so many words here, all the descriptive words, all the ChatGPT buzzwords for what it is. We all know it, we all have some form of idea of it. But basically, if you summarize it, isn't it everything? Like, from different perspectives, it can be usability, reliability, all the ilities. If you boil it down even further, we have requirements, we need to do those, we have design, test cases, which tools we use, the workflow we have, good hygiene in Git is important, if we are agile, if we're not agile, depending on what kind of religion you're following. And of course, not to be underestimated, we need good coffee and tea, because we also need to survive. So we need to be good humans, and we need to do that. And that is a part of quality, that's my point. But, excuse me, is it me? So, but from my perspective, it's not really everything, because the customers and the clients, so to speak, and the governments needs us to show compliance to standards. So our main goal, to show that we are fulfilling some form of quality. This is not everything, but it is one important part, one leg of it, we can say, is that we have flying software. We need to make sure that we follow correct standards, and we need to show that these software is compliant against that standard when we declare it and when we want to fly. That's a really important part, especially since no one wants the airplane to go down or crash, especially not us. So what does it mean? So strictly speaking, I can only talk about software in the Gripen aircraft. I cannot talk about other civil aircrafts and whatnot, because I don't know. But I do know this very well for the Gripen aircraft. So basically, the Gripen project has a design organization, and we are allocated different responsibilities on this design organization. So engine, we have the boost, we have the pumps, we have the screens, and we have part of it being responsible for the developing of the software. Also the software process, not only the software. And this means, in a very long and not very stringent way, that all the software declared in the software need to follow our process. So we have a process that says you're supposed to do all these kind of activities, and you're supposed to show how you inspect the requirements, how you do testing, how you do design, and you need to follow those activities and standards. And what we have done is that we have created a process that is mapping these activities more or less one-to-one to objectives in a standard. And for flying software, we are using the standard, well, it's just an acronym, but RTCA DO 178, B or C, depending on which year your product is created. So if we then have software that follows the process and says that we have done these activities, we have showed this for our testing, for our cases, test cases, for our requirements, and for our code, we can say that in the end, we are showing that all the software is compliant to our standard. That's the whole point. So an example of how this works. We have some form of system level where we say that software is supposed to function in a certain way. Basically very, very high ultra level requirements saying that this software should control the radar. It's very unambiguous. We have no idea how, but that's what the system level says to us. And from that, we can allocate or create software functions on our software, which is basically high-level requirements, saying that this software should do this when the event comes in and send signals, and so on. And all of this design in the software is then also traced to the same software functions. So all, that was not me. The software itself needs to implement the design that is traced to the software functions. That's also really important. And here we can also, in the design phase of it, we can add some form of low-level requirements. This is where usually users tend to know what requirements means. The function X should do this when added this. So this is very low level for us. High-level requirements is more, the software should, in this scenario, act like this. And then, based to the same requirements, both high and low level, we have something called verification cases, which is just a description of when testing this kind of system or this kind of function, we should add this data and expect this behavior out. So it's some form of description between a requirement and a test case. And in the end, we have test cases tracing to these verification cases. It's a very, very linear curve, but very many documents and artifacts describing what we should do. And the point of this is that we can have traceability from test cases all the way up to a system level description. So somewhere it says that the software should control the radar. Then we can measure, okay, but doesn't that mean when we go left or right with the stick, something should do? Yeah, and we can find that in test cases, tracing all the way up. That's the entire point. And that's what the standards tells us. Traceability is key. I see that it has cut off the word traceability on the left, but that's the whole point. Everything should be traceable to itself, upwards and down. And of course, in the end, we have some form of result for our test cases or our manual inspections or whatever it is that is also traced to this kind of things. So everything is traced to something mandated by a process. So we did this. I'm going to give an example for where we did this, but it didn't go so well. But the point is that we create. The point is to show you where some part is important, where we missed, but we follow the process. So some little background about this. We created a software tool, which is basically just used in some form of development process. It can generate code, it can generate data that is supposed to go into the aircraft, or it can be some form of test tools that is just running to create logs and whatever. But basically, tools for flying software is subject to the same kind of activities. That's the whole point. So we do the same kind of thorough testing, thorough requirements and whatnot. So we did this. We tried to go all the way. We did everything by the book. We had requirements, we had design, we had all the test cases, we had so many inspections. All the different people and different users, in some sense, had their voice heard. And we had inspections, formal inspections, where we go towards like more chief engineers that are looking at our stuff, saying this will work, this will be okay, this will be accepted by our customers and whatnot. We also had inspections where it didn't go so well, which is called rage-fueled inspections, where we shouted at each other. But that's the whole point, to voice our opinions. Maybe you don't need to shout, but we did. And we had perfect testing. Obviously, we didn't, but we had testing to the fact that we traced everything our requirements said, and we did everything our requirements mandated. And still, in the end, when everything had passed, and we had our declarations and our documents, and we could release it, and we had our little party where we ate cake, because this was a complicated software, something went wrong, because users in 2 or 3 weeks told us this is not usable. We have no idea how to control it. The software is not acting the way we think. It's hard to manage. The UI or the configuration of it is horrible. So along the way, we realized we missed something here. We had requirements for it. We had users with us that wanted to be a part of it. But obviously, we followed the process. We had everything. We did certification and declaration according to a process, and still it turned out bad. So what did we miss? Well, it's obvious. It's the user. They had no idea what we wanted to do. Or they had idea what they wanted, but it was not what we created. So in the end, expensive software, thorough process, came out in the end. It still works. It's still the same software. We had fixed it a bit, you can say. But the user was not happy with in the beginning. So that's my entire part of it. Usability, as you wrote. We kind of skipped it. But we had everything correct. So from the perspective of process owner, I would say this is perfect software. Obviously not. So what I'm trying to say is, in a nice transmission way to Claus here, in some sense, if products are supposed to fly and software is supposed to be compliant, we must say that all software or products are compliant. And that also means that all good products are compliant. But are all compliant products really good? I mean, obviously not. We have created software that's not that functional and that is not that good. So some aspects is not covered in this compliance matrix. And how do we actually get to that? Yep.
Thank you, Niklas. Any questions?
To the example you gave. So you delivered a perfectly good quality product. It's just maybe not what the users expected, and they didn't like the change.
They didn't really know how to use it. It was very complicated to use. You had to configure it in 10 different ways.
Okay, but it worked fine.
It worked perfectly fine. It's so good software, but
so it's kind of the lesson there that actually the change management bit after the cake is almost as important as the product.
Oh yeah, definitely. Yeah. The life cycle of the product, how it evolves, and how you do change management and how you do problem reports as well. Yeah. Also very important, because that's what we did to fix it up. It's still basically the same software, but with a different UI and different how you configure it.
Makes sense. Thank you.
Okay, well, since it's almost Christmas, everyone who asks a good question will get a nice Christmas present from. So here you go. And a good question is defined by being one of the 10 first to ask you. So
You tell them that now.
Okay, any more questions for Niklas? I thought we had one over there, right? No?
Yeah.
No. Or do you just want a Christmas present? What's the Christmas present?
So I was wondering, because there was the test cases that you mentioned, and then the usability was sort of not that good. How did the test sort of not capture this? Was it like people who already knew the software that were carrying out the testing?
It was more that the testing was basically testing how the software functions, where we put certain values into functions and how we, when you configure the tool this way, it should act this way. It did it perfectly, exactly like that. But we didn't consider this configuration part. Is that really nice?
Right.
So it comes down to, are the requirements good? Which, they were because they tested the right thing, but they were not good because that's not what we wanted, or at least what the user wanted.
Did this sort of push you guys to include more the users in the process of testing?
Yeah, definitely. Usually now we have more or less that in some form of standard way when we do new tools. We try to include them in the beginning. Is this what you want? Or
right.
But still, it's the same problem everywhere else. If the users are supposed to be involved very much, they need to prioritize their time, which we all know no one has. So. Right. So it's better to just ask very informal, is this what you think? Is this what you want? And then to try go that way.
Yeah, so it doesn't delay the process as well?
No, exactly.
Yeah. Okay.
Yeah.
Well, that was actually 3 questions, but you don't get 3 gifts. That's not how it works. I'm sorry.
You can only get 1.
There you go.
I have one question regarding the requirement management
Mhm.
and how do you analyze the requirements before you put it into the software? And there is a review process for the requirements
Yep.
as well, so that the developer who takes the requirements and develop the software does not misunderstand
Yep.
what it's supposed to be. In your world that you have understood one way and then you have created a product, but it didn't work the way it's supposed to be.
Mhm.
So could be possible there, the re-review of the requirement should be done before they being agreed and delivered to the software developers?
Yeah. I mean, that's also part of it. My guess is the the requirements reviews they were good, but we were the same people who had the responsibilities of the tool who were
Mm.
reviewing it. So that's even we made errors. So
Yeah, that was a good traceability diagram that you have shown,
yeah.
like from the test cases all the way up to the requirements.
Yep.
So at some point that should have been triggered even before
Yeah.
you come to the end software delivery, before the test cases trigger, okay,
Yep.
something is not working.
Usually, the system level takes care of this kind of stuff when they say this is how it
Yeah.
should be used, or at least. Because for software in the airplane, maybe it's like you're supposed to control the radar this way. Then you get the feeling, okay, so it's not XML files. Okay, I get that. And
Yeah, and you also mentioned, I'm interested in, like, you use some software to generate the code as well.
yeah, some software tools do. Yeah,
Yeah. Do you use any model-based design or?
yeah,
Okay.
that's what I meant. Model-based engineering.
Simulink or?
Yeah.
Thank you.
I'm curious to see what kind of tasks they needed to configure your users that they couldn't. I assume they're not a bunch of idiots, so
No, they could. It was just very hard. And basically also the manuals for it, for how to control the tool and how to configure it, they are only as usable as the user understands. So the tool was new, it was very complex. We made it and we wrote the manuals. Not a good combo, because we know exactly how it works. You just write this and it's okay. Doesn't really work that way when users don't know how to use it, first of all, and then it's a new thing.
so what kind of task? Can you tell us, like, what
Basically,
kind of
you write configuration files in XML files, like 5 different files that controls this. So it's something that is used in the build process of the software. Then we use the same. So you need to configure that one in a specific way, without saying too much.
and then how did you fix it?
Basically made guides and made templates that is already functional from the beginning. So the tool assumes stuff in the beginning. That's how we
So you
fix.
cut the process.
Pretty much.
I think
tool-
we need
the tool-
to. I think we need to move on, and like I said, we will be here later. Thank you so much. Thank you, Niklas.
Thank you.
Right. So, to sum things up, this kind of quality is quality in the eyes of the authorities, right? And it's basically a way to build trust, that you can trust this airplane and the software in it. One way of doing that, of course, would be, here is the source code. Feel free to review it. And that's possible, I suppose, if the amount of source code is manageable. It is not in a modern aircraft. So instead, what we do is we say, we promise that we will follow this process. And the authorities look at the process and say, okay, as long as you promise that you do that, we can trust this software, right? Is that good? Good way to sum it up? Yeah. Well, with that, welcome, Claes.
Thank you. Let's see which one I'm going to press here. All right. So now we've been listening to the process part, and that's obviously needed. And but there is another point, another view of it, and that is how we do it for real, so to speak. And that's where I come in as a system architect. So this will be from my point of view. Let's start talk about me. My name is Claes Fridén, obviously, and I'm a senior system engineer at Saab. I've been over 25 years at Saab, and I mainly work with not the aircraft itself, but with support and training systems. That's what I do. I have currently 2 roles at Saab. I'm something called design authority, and I'm a system architect. To kind of the difference between them are that the design authority is more like a what, and as a system architect, I do the how. I actually design the systems or create the system, right? And when I put my design authority hat on, I'm more in the process world, reviewing documents and taking hard decisions and stuff like that, and so on. The things I work with right now is that for Gripen fighters solutions, simulations and support systems, and I'm in training systems where I am mainly focusing on pilot training, and I'm also in the training systems for digital training where I focus on maintenance personnel training for both of them. And just to be specific, when I'm working with the pilot training, I'm the system architect, and I'm a design authority when I'm working with the maintenance personnel, but it's kind of the same and so on. And obviously, software quality is very important in both of these roles, either in the process way or as a system architect, more in the hands-on, in the code and in the system itself. So. And these are examples of the two products. The Gripen Mission Trainer is the simulator of Gripen, both C and E. And it's the simulator, obviously, there. And for the maintenance personnel, one of the tools and one of the systems are the Virtual Maintenance Trainer. It's a Unity game where we actually can first person do the maintenance procedures on the aircraft. For practicing purposes and to learn the manual and so on. Any questions on the tools right away, of the products? No? So let's jump into what is software quality. And I can say that the first slide that was shown from the audience with the words and the one-liners, that was pretty good. I mean, these words are going to pop up in this presentation, obviously, because that's what's really, really, really important. And just to start off with, all the words are important, and that's what makes it so hard, because there are like a million aspects to this, and you might fail one and or another, and the consequences might be big or small, you don't know, unless you plan for it in advance, and that's where I come in. So just to say that summarizes it very good, all your words. So what is software quality for me then? This presentation is going to be from my point of view, from my experience. So it's not going to be like the silver bullet or anything like that. It's going to be from my perspective, my personal perspective from Saab, from where I have worked on projects that were successful or not so successful. So obviously it's to the degree of which the software meets the requirements, but that's kind of obvious, and that's more to the process part, unless we talk about actually maintaining the requirements themselves. You were kind of into that a little bit. You can have a lot of requirements, but they're all crap, and that do you nothing. But you have 10 of them that are real good, then you're going to be much better off. So that's something you have to work with. You have to work with the requirements all the time. And that's a privilege, I'm going to say, that I have that you don't have, because I work on support systems and training systems. We are not up in the air. We cannot fall down. So that's a difference. We still have to think about safety, because it's very important that we can have something like negative training or stuff like that. It actually makes stuff fall down later on. So you have to think about that, even that we don't have to follow that standard. So as you were talking about. So for me, it's more like reliability, usability, and maintainability. These words were kind of your top words. And we have to not just look at the requirements. No, we have to look at all aspects. So there are both functional and non-functional aspects to take care of. So this is part of the initial stage when you do like a new project or you're going to do a big change or something like that, you have to think about not just what everybody's telling you. You kind of have to think outside the box and find what else can affect this that you have to think about for just this project. And that's when all these buzzwords comes in, because that's where it starts. Even though it's buzzwords, you have to start there. So you listed a lot of words. I listed a few. But if I would do this for real in my daily work, I did this today. I can take that as an example. I had some differences between different subsystem owners that want to do something differently. And then I take these back, but I had a much longer list. And they have to not just say what they want and think they want to do. They also have to answer for each and one of them. They have to tell me, your solution, is that good or bad for that one, that one, that one, that one, that one? What will that bring to the bigger picture? That is very important to do that. Otherwise, if we don't do that, we're going to do something that is really bad for software quality, and that is use emotions or history or think we know and stuff like that. We have to kind of take that out, and to do that we use the buzzwords, and we use them for real. You have to talk about them, you have to explain yourself. You might say not applicable for some of them, of course, if it's not applicable, but most of them can be applicable if you really try. So for me, since I'm an architect, for me the system architecture is very important. And this is where it all starts. If you do this badly, if you don't take it seriously, or if you don't do these buzzwords, and doesn't give it the time or the love they need, you will end up with bad quality in the future. It's one thing if you do like your projects at home, or your small software, or something you're just going to deliver once, or something like that, then it's totally different. But that's not our world. This is not how we do it. It's not how we live. The systems that we do or develop are big. They live over a really long time, and they have life cycles that goes on and on and on. And so if we do big mistakes during this part, it's not going to be easy for us in the future, basically. So that's why the architecture actually is important. So if you have a good architecture, it ensures structure and supports quality, obviously. It will enable testability, enables maintainability, reduce complexity, and support scalability, and much, much more. I'm just taking a few buzzwords because they are like the first page you had. It's actually that many. There might be fewer than your the first slide, but because there were kind of same words a little bit of some of them, so you can kind of merge them together. So, but so like I said, this is where it all starts, and that is actually really important, and that's what I do during my daily work. Also, to get, if you have this, you have it. You need other tools to actually kind of. You need tools to get matrix of your quality. You can do like reviews and stuff like that, but in a system that we are, these huge systems, it's really time consuming, and it actually can end up with missing stuff, and you get different opinions and stuff like that. So usually I like to have a lot of tools for like complexity matrix, so you can find where you need to kind of put your effort. If you want to do some refactoring, you need to keep your refactoring going. Always take the worst code and fix it, and don't let it just slip out of your hands because it's going to be heavy in the future for you. So take as much tools as you can, like static code analysis or dynamic code analysis. This is very development environment heavy, so make sure, like my last sentence, make sure you have the correct tools for the job. That will be much easier for you. I have been in many, many projects where you have like a tight budget or you get cheap and you don't do this. You say, I'll be good. Yeah, for a little bit. Until you have a lot of code. And then it's not that fun anymore. And you will just end up with a system where you have failures or bad performance or stuff like that, and you don't know where and you don't know why. And even if you manage to localize the problem, it might not be that easy to fix it without breaking anything else. So, at least for me, I take tools very seriously. I bug my bosses about that a lot. Give us the correct tools. We need the tools. We need to have the tools. Very important, because the tools today are very, very good. So I also mentioned test coverage, and since we are not in that process world that you are, we don't actually have a requirement for test coverage, which is nice, I think. But we want test. We want automatic testing. So we need test coverage, and we need test coverage tools. And that is not to actually find all the bugs or make sure that people write the perfect tests, but it is to see when we stop doing the tests. So we can measure when we stop doing the tests, right? That's what we need it for. Otherwise, it's very common that we kind of end up saying that we have a lot of tests, but in the end we don't, because you kind of stop doing it because of time or just because people don't want to. So, of course.
Is it this test coverage also reported to the system level as the test result has been connected all the way up?
It's actually, in the way I do it, it's actually all the way up. I actually write it as a requirement. So even the people that's actually testing the system, they will end up with a test case where it says, go to the architect, make him use the tool, and tell you the test coverage percentage. And if it's below this number, it fails. This is how kind of hard or bossy I am at that one, because I want it to be for real. And the best way to make something for real in our world is to write a requirement. And that's how we do it. So.
And the static code analysis, other code analytics, what kind of tools which tools do you use, if I can ask?
Oh, it depends on if you are working with like C++ or C, what they do there, or if you are more on the front end part, it might be Microsoft stuff, so it's Visual Studio and all its tools, so ReSharper, for instance, if we add that. And Visual Studio today have all the tools basically you need. And if you need more, you can add ReSharper. I think that's what we usually do.
And all these code analytics should be done against some standards. Like, for example, automotive, you use Mistra standards. Like, do you have any?
Yeah, I try to use as much of Microsoft standards as possible, basically, because I have found that once you start playing around with it, it gets out of hand. And I have had projects where I spend a lot of my time just discussing these rules. Instead of implying the rules, instead of writing codes, we're just talking about, I don't like this rule, I like that rule, I want my code look like this or this. No. So you have to, that's also why you want this code analysis. So you get, before you kind of wrote these documents describing how you wanted the code, and nobody read them, and they got too big, and nobody uses this, and it end up in the garbage. And so this is much better. Use the tools and just don't edit them too much, because Microsoft, or ReSharper for that matter, they know what they're doing, so leave that to them. That's at least my opinion.
Super simple, but are you putting this all together in like a continuous integration pipeline, making sure that all of this is being done on all of the code, on all of the branches, and sort of getting, so you get like a complete overview constantly of this as it's happening? Or because you talked about that people are maybe not doing the tests and so thing, but if you I would imagine that you would try to build a system out of the tools to make like a big thing that runs automatically. You don't have a choice.
Yeah. All of these tools are actually during nightly build. So I mean, it's a continuous build at least. It doesn't mean it have to be continuous integration, but it definitely nightly build. Some of them are, of course, tools that are used during when you write the code, but you see it right away. But I think my time is, I'm halfway. Relax. I'll speak faster then. This is so fun. Software testing. I will do it at multiple levels, of course. Unit testing, integration testing, system testing. This one is most important. This is very important, and kind of one of the ones that we miss, the regression testing. We say that we have it, but do we really? So it's very important that we have the confidence to refactor the system, and we know if we do something wrong, it's okay, we're going to find it. That's what it's most important for. So we give the developers the confidence to just do it. They don't have to think so much. If they do something wrong, the system will find it, right? And obviously we have verification, and that's more against the requirements. So, and then we have the thing that would have found your mishap with the good code, but it wasn't usable. We have the validation. So, and validation is it built for the right thing? Is it useful as intended? And this is not something we do. This is given to the users or appointed use by the customer. So they actually test it and see if it can be used for real. This is something that I think is very important, and now we're into the usability part, obviously, a lot. And if you take this out of the equation, you're going to build a bad product. It's not going to be useful. That's just the way it is. Because in our line of work, I mean, fly much? Nope. Do I do a lot of, am I an instructor for pilots? No. I don't know what they want to train. I just do code, basically. So this is very, very important that you have, and you have a close loop, feedback loop, because that's usually also where it fails. You say you have this, but you meet like once the third year or something. I mean, something like that. No, it has to be continuous integration, continuous delivery, and stuff like that. And that is kind of hard in our line of work because depending on because of the nature of our systems, we can't just put it in the cloud and somebody checks it out and brings you some feedback. No, it's harder, but we still have to do it. And in the end, obviously, this reduces a lot of rework because we might do the good functionality right away. So it doesn't matter if we have the process. It doesn't matter if we have all these automatic tools and testings. If we build the wrong thing, it doesn't matter really. And it's very important, at least for me, that our systems are great because they are used for something important like protecting my family. So it's very important that the pilots are the best pilots that we can have. So it's important. Sorry, I have more slides. Best practice, and let's do this quickly then. I think you should just, the architecture is really important. If you do wrong things in the architecture in the beginning, you will not be able to do all the testing you want, or the in our case, like interoperability, when we have to actually connect our system to other systems that we don't produce, you won't be able to do that. It's going to be hard. And so you have to put a lot of thought into your architecture. That's just the way it is. The tools, very important. We have a lot of code, a lot of functionality, a lot of customers, a lot of variants and stuff like that. Automatic testing is essential. Same thing with code reviews. No, use standards and use tools to that. It's going to be too hard. Continuous integration to get the feedback from the system itself, and then continuous delivery to the users as much as you can, basically. Very important. And use standards and obviously document everything you do in the proper way. So, and that is the key part of that. And now I felt a little bit stressed at the end, but that's the way it is. Just like developing our systems, you get stressed in the end if you don't have this. So, thanks, I guess.
Thank you, Claes. Nice finish there. Now, before we move on with questions from the audience, we have some questions that have popped up online, so we will do some of them first. But unfortunately, technology doesn't allow us to give out gifts to those questions there. But I have one for you, sir, because you asked a question before. Here you go. So, Aaron, could you please do some questions from the online streaming, and we'll see which one of us is fit to answer.
Okay, just pop this up. So this question that we have here, the latest one, was what role AI started playing in the overall system architecture?
Oh. Big question. We obviously do a lot of work with AI. I'm not sure how much I can speak of that, but we use it. If you think about architecture, obviously AI is an aspect we have to take care of when we do the architecture these days, like an aspect of all these lists you have with words, with buzzwords. And we are getting more and more tools that actually use AI for just if you talk about quality. So the tools are getting better by using AI. And if we are talking software quality from my point of view. AI, other words, if you talk functionality, something else, but now we're talking software quality, so then it's obviously tools to help us do the reviews and give us good design patterns and all stuff like that. Was that an answer?
Yeah. And there was another question also before. It was, what prevents you from developing the perfect software?
Nothing. I would say bad planning, not realizing all the buzzwords, not taking care of them in the beginning. Yeah. Otherwise, we have all the knowledge and all the tools we need, basically. Still, we don't do it. But yeah, what is the perfect? That's a good question. That's a tough one. I think it's because we have so many aspects that we kind of get lost, I would say. So you're never going to get to the perfect one. What's the fun in that? Was that an answer? I don't know.
Okay, yeah.
It was a tough question, though.
Yes, so thanks for the questions online. And I see that our food has arrived, but I wonder if, do we have time for...
Yeah, at least one or two more questions, I think
yes.
so, yeah.
Ah, perfect.
Thank you. So I have two questions, actually. I have one about...
you only get one gift.
Okay, I will only get... Okay. But I get two questions even though I get one gift?
Yeah.
Okay.
Go ahead.
Well, then it was three questions because... anyway. So you you mentioned that your softwares, of course, are very durable and they last for a long time. But I'm guessing that you also face moments where the tools that your software depends on might update, become obsolete, or you know that they're going to stop being maintained. And how do you kind of account for that or prepare for that without breaking the whole thing?
First of all, you have to acknowledge it, just like all the other buzzwords. You have to know that that's going to happen, and then you have to migrate the risk, right? So either you can write all the tools yourself. That's one way. Usually doesn't work. Or go with some safe bets. I mean, use big development environments like Microsoft stuff, of course. I mean, and or well, that's basically it. I mean, if you will be committed into one system, either way you like it or not, it's going to be a big change. But code is code, so it's just code. You can always move it, but there will be some consequences. But let's say the easy ones, that you have a new version of your tool. That still can be a problem. You still have to count for that. You still have to plan for it. Don't do it the days before the delivery, basically. Do it the day after the delivery and stuff like that. We do plan for that. Or if it's a new .NET versions coming out or whatever it is. You don't do it. Select your point in time when you do it.
But it's a very valid question when it comes to the flying software, because there, I mean, if a plane crashes, it could have software that we developed 20 years ago, and we need to be able to test that. So what we need to do is that every time we make a build, software build that we are intending to fly, we need to know exactly what version of each and every tool that is used for that build, right?
Yeah. So basically, the same configuration management that applies for code that is flying or binaries or whatever, the same applies for tools. So we need to be able to reproduce or recreate results.
Yeah. So we not only do a software baseline, we also do a developer environment baseline.
And that's the difference between having like flying products and not. We are not that open to use new stuff because we need to control how they work and how they change, so to speak. So in one sense, open source is better, but maybe they are not. If they are changing fast, it's even harder for us. So it's a very trade-off there.
And my second question is, in your experience, when is the best moment to introduce user experience testing? Because you cannot put it from the start. So when is the best moment?
From the start.
From the very
yeah, that's my opinion. Right away, day 0. I mean, the products that have been in my career the most successful, that's when they are with us from the start, basically. Not every day, but they're in one project. Many years ago, we worked with pilots, and we actually had some retired pilots that didn't have much to do. They were older, so we had them at our side the whole time. And that was a big success story because they could tell us after 5 minutes that we were stupid and we did something else.
And what you can do even with flying software is that you can do a quick mock-up, for example. So this is what we imagine the user interface will look like.
Yeah, we basically do prototypes very early. So before we even go to like development, before we have the system level requirements, we try to do some form of prototyping. And that we can do in simulations, and we can try it in the simulator where we see, does it work in the airplane as we want? Obviously, it's just a mock-up. Then we get feedback from other users who know the system or pilots.
Well, you know what? I think really we need to stop there. But like I said, we will be here. And for those questions online that we did not have time to answer, we will try to do that in the comments below the YouTube clip, right? Okay, so with that, thank you very much for listening. Thank you.
Thank you.